let us discuss sum of first n terms of an AP. Okay, let us take the AP as, let us write the sum as Sn and the AP as A, and then second term A plus D, third term A plus 2D, finally the second last term as A plus n minus 2D, and the last term as A plus n minus 1 into D. Last term, or you can say nth term, right? So I need to find the sum of n terms of an AP, right? We already have this in our mind that if I add this A and this last term here, it will give me the same result as this plus this second last term here, right? So let me write this same sum or the same expression that is on the right hand side here in other way around, that is in the flipped form. Let me flip it. Let me write the last term first and then first term in last. A plus n minus 1 into D plus A plus n minus 2 into D, and so on. A plus 2D, A plus D, and then the last I'll write A. So I have not changed anything in the expression written on this right hand side. I have just flipped it and written it in another form, right? I have not changed anything here. Now if you add these two, what will you get on the left hand side? Twice of Sn, twice of sum of first n terms of an AP. Now look at the first term of both these sequences, this and this one. If you add first term here and first term of this expression, you will get 2a plus n minus 1 into D, right? Now if you add second term of this sum and second term of this sum, what will you get? Here you have got n minus 2D, and if you add 1D here, it will be n minus 1D, right? So 2a plus n minus 1D, right, which is nothing but the same sum that we got by adding first terms of these two series. This also gave us the same result. Third term of this sequence, third term of this sum and third term of this sum will also give us the same result, and you can verify the last term plus last term. A plus a, 2a, n minus 1 into D. So last term plus last term will also be 2a plus n minus 1 into D. This is something that we have already discussed in our previous lecture, right? So each of these additions gave me 2a plus n minus 1 into D. How many 2a plus n minus 1 into D's? Because I have got n terms in this sum and n terms in this sum, so I'll get n terms in this resulting sum also. So I will have n into, that is these 2a plus n minus 1 into t written n times. These are written n times. So what can I say about twice of Sn? That it is equal to n times 2a plus n minus 1 into D, right? 1, 2, 3, 4, n times. So it is, what do I mean is, if I write 2 plus 2 plus 2 3 times, I can write it as 3 into 2. If I write it 2 plus 2 plus 2 plus 2 4 times, I can write it as 4 into 2. If I write 2 plus 2 plus 2 n times, I can write it as n into 2. I hope you understand this much, right? So now look at the sum. This is twice of Sn that you have got till now. This is twice of Sn, right? So what will be Sn? That is sum of first n terms of an AP. It will be equal to, I'll divide both sides by 2. So it will be n by 2 into 2a plus n minus 1 into D, right? So this is the sum of first n terms of an AP, where a is my first term, D is the common difference, n is the number of terms, right? Now you can observe that 2a plus n minus 1 into d is being multiplied with n by 2, right? You can see when you see this sum here, you know that first plus last, second plus second last will give you the same result, that is 2a plus n minus 1 into d. So how many pairs will these be? These are n terms, so there will be n by 2 such pairs, and each giving you 2a plus n minus 1 into d. So n by 2 into 2a plus n minus 1 into d. Actually this method is inspired by something that Carl Friedrich Gauss used while solving a particular problem given in his class, right? When he was a kid, he was given this problem by his teacher as a punishment, that you need to add first 100 natural numbers, 1 plus 2 plus 3 plus 4 up to 100, right? And he was given this problem, and teacher expected that he will take complete day to solve this sum, he will for this addition. Now this guy Carl Friedrich Gauss, what he did was something magical. He thought is in mind and flipped this sequence and wrote it like this: 100 plus 99 plus 98, right? 2 plus 1, and then he added these 101, 101, 101, 101, right? And this is twice the sum. Okay, if this is s, then this is also s. He added these, so this became twice of s, right? 100 into 101, 101, how many times? This was written 100 times, so twice of s became 101 into 100. So s is nothing but 101 into 100 by 2, that is 50/50. All right, so this is how this question was solved by him in few seconds, and teacher was very surprised. So we have used the same method here to calculate sum of n terms, sum of first n terms of an AP. Okay, let me talk a little bit more about this formula that we have got here. In this formula, if you notice, this expression that is written inside the bracket can be broken into a plus n minus 1 into d. Now this a plus n minus 1 into d is nothing but nth term, and a is first term, right? So if this is first term and this is nth term, sum of n terms can also be written as a1 plus an into n by 2, right? So this is another way of looking at it. Now let me write it once again and discuss something else. Sn is nothing but n by 2, 2a plus n minus 1 into d. This is sum of first n terms of an AP. Now if I open this bracket, right, if I multiply this n by 2 into this 2a, 2 will get cancelled and it will be n into a plus. Now I multiply this, if I'll multiply this n by 2 into this expression, so it will become n square by 2 into d minus n by 2 into d. Okay, let me write it in standard form, that is, let me write the highest power of n first, n square, and let me write d by 2 as its coefficient. Okay, I am writing it as a quadratic equation because it is a quadratic equation in n, right? And then a minus d by 2, a minus d by 2 into n. So sum of n terms, sum of first n terms of an AP is a quadratic expression in n, right? Sum of first n terms of an AP is a quadratic expression in n where the coefficient of n square is half of common difference. Coefficient of n squared is half of common difference, right? That is, the leading coefficient is half of the common difference. So sum of n terms of an AP is a quadratic expression in n with constant term as 0, right? There is no constant term here. So let me write it for you so that you can take a note. Sum of first n terms of an AP is a quadratic expression in n, quadratic expression in n with coefficient of n, with coefficient of n as half of common difference, common difference. So if I write that sum of n terms of an AP, sum of n terms of an AP is equal to, let us say, 3n square plus 5n, right? So I can simply say that this, if I write that sum of a sequence, right, sum of n terms of a sequence is 3n square plus 5n, I can identify that it is a quadratic expression with constant term as 0, right? So this is an AP, right? And what is the common difference of that AP? Common difference is double of this, that is 6. So the expression here is sum of n terms of an AP. First thing that you can identify here is this. Second term is that AP will have a common difference 6, because the coefficient of n square has to be half of common difference. So just by looking at this expression here, you can see that this is sum of n terms of an AP, of which common difference is 6. And can you say something about first term? Yes, because if I put n equal to 1, it will be nothing but sum of one term of an AP, that is the first term, right? So S1 is nothing but the first term. So if I put n equal to 1 here, I will get 8. So this expression here told me two things. One, just by looking at coefficient of n square, I could say that common difference of the AP, of which this is the sum of n terms, is 6. And what is the first term? If I put n equal to 1 here, it will give me the first term of that AP. So the AP that I am talking about is 8, then I'll add 6, 14, add 6, 20, and so on. Whenever you write a sequence, you have to write at least 3 terms so that the pattern after that is clear, right? Now, because I know what will be the next term, see, 8 plus 6, 14, plus 6, 20, plus 6, 26. So pattern is clear after you write the first 3 terms, right? What I mean is, if there is an expression like this, sum of n terms, sum of n terms of a sequence Sn is given as 2n square plus 3n, let us say. Sum of n terms of a sequence is given this. Find out whether it's an AP or not, and if it is an AP, write the first 3 terms of that AP. If, let us say, this is the question. Now just by looking at this sum, you can say this is a quadratic expression in n with constant term as 0. So it is definitely an AP. Second thing that you can see is that coefficient of n square is 2, which is half of the common difference. So you can directly say that the common difference of this AP is 4, right? And third thing that you can observe is that this is sum of n terms. So sum of first term, that is itself is the first term, right? So if I put n equal to 1, it will give me my first term. So first term is equal to 2 plus 3, that is 5. Now if I have to write first 3 terms, I'll write first term as 5, second term as 9, third term as 13, right? 5 plus 4, 9, plus 4, 13. You can keep on writing all the terms like this. Okay, so this is what we observed about sum of first n terms of a AP. Okay, now let's continue in the next video.